So today you have homework sets in series. It covers 2.4, 2.5, and 2.6. Quiz 3 is due tonight. Okay, everybody? And I told you quiz 3, if you look at the 2.5 transformations. Remember that 2.5 practice problem? I told you is on the website. Make sure you finish it before the quiz. Okay. So this 2.5 practice problem and answer. Make sure you understand every step. Is that clear, everybody? Okay. Yes. So that's the quiz. And so let's keep going. Today, we're talking about section 3.2 and graph polynomial functions. So here are the steps. We factor to find the zeros. So zeros is you set f of x equal to 0 and you solve for x. That's the zero or root of the function. Do you remember that, everybody? Mm-hmm. And then they also give us the x-intercept. So x-intercept, the y-coordinates is 0. And then these give us the x-coordinates. Do you remember that? And then to find the y-intercept, you plug in x is 0. So f of 0. But in our example 4, so make sure you do the quiz tonight, okay? And before you do the quiz, check out the 2.5 practice problem and answer on the course website. Yes. Okay. F of 0 is 0 for this problem. So the origin is both x-intercept and also the y-intercept. Okay. That is the first step. Find the x-intercept, find the y-intercept. Second step. Okay, second step, 2 methods. Method 1, test points. You see the x-intercept is separate the x-axis into a lot of pieces, right? And for the test point method, on each piece, you pick the test point. So we pick 4, and then you plug into the function and see whether it's positive or negative. Questions. Do we plug in the original form or do we plug in the factor form? Factor form. Because factor form, you just have a product of a bunch of things, right? And you count how many negative signs. If you have an even number of negative signs, you will get positive, right? If you have an odd number of negative signs multiplied together, you get negative, right, everybody? So don't forget we have a quiz tonight. Okay, so review the 2.5 practice problem before you do the quiz. All right, so that's why f of 4 is negative. So that means f of x is below the x-axis. So you connect this point and you go down. And then this piece we plug 2. You can also pick 1. It doesn't matter. No matter which one you pick from this interval will work. So f of 2, plug in the factor form, is positive. So we know the function lie above the x-axis. Here we pick negative 0.5. And you see positive, negative, positive. So the answer is negative. So below the x-axis. And then this piece, we plug negative 2 to the factor form. We get positive, negative, negative. The 2 negative make it positive. So therefore, our f of x is above the x-axis. Then this is how we graph the polynomial. You can see it's very smooth and continuous. Okay, everybody? And be careful. Don't draw something like that. No, polynomial is very smooth. Like you play the roller coaster, right? And it's not like a corner. Okay, everybody? So this is method 1, okay? And determine the end behavior. Look at this. Look at the end behavior. So on the left, x goes to infinity or minus infinity. Negative infinity. So x goes to negative infinity. How about the y? Positive infinity. Very good. How about this side? The y goes to negative infinity. So this is the first method when we pick test points on those intervals. Okay. And I would recommend you to use the second method. We have a second method. But before we go over the second method, let's go to the next 2 page, multiplicities. Okay. So if x minus c to the power k is a factor of the polynomial, we say c is a root of multiplicity k. For example, you might have f of x equals -5, 3x minus 1 square, x plus 7 cubed. Something like that, right? And when you find the zero of it, you set it equal to 0, and then you set each factor equal to 0, right? By the way, the -5 is just a constant. It has no x. So you don't set this factor equal to 0. But you set this factor 3x minus 1 equal to 0. So 3x minus 1 equal to 0. And you set the factor x plus 7 equal to 0. Right, everybody? And when you find the root, you solve for x. Therefore, you get 3x equals 1. X is 1/3. And then here you subtract 7 on both sides. You get x equals -7. So the 0 or the root is 1/3 and -7. Multiplicity is the corresponding exponent of that factor. Do you see x to 1/3? That corresponds to the factor 3x minus 1. Right, everybody? Because that is how you get this root. You set this factor equal to 0, you get this root. So this root corresponds to this factor. And can you see the multiplicity is 2. So the exponent of that factor in the factorization of the polynomial. Okay? So how about -7? What's the multiplicity? X plus 7, the power is 3. So the multiplicity is 3. How about here? X equals to 5 has multiplicity 3. And 1 has multiplicity 4. Okay, good. So that is the exponent of the factor. Okay. If a root has an odd multiplicity, so odd number, okay, then the curve will pass through the x-axis at the points. So cross. Okay, so it's like that from the below to above, or from above to below. Cross the x-axis. Okay, everybody? And if a root has an even multiplicity, then the curve will bounce up. Okay, bounce up, which means go to the same side. Okay, so you go here, bounce up. Go here, bounce up. You don't cross the x-axis. Is that okay, everybody? Mm-hmm. All right, so look at the following. Determine if the multiplicity of each zero of p of x is even or odd. Okay, look at here. Even or odd? Odd, because we cross, right? So this is odd. Okay, how about next one? 0 here. Even. Yes. Next one. The -1. Even. Right, everybody? So that is multiplicity. Good. Any questions so far? All good? Mm-hmm. Okay. Now we can go back to the second method. So we said the first method was test points. Second method is use the factorization. Look at the multiplicity. Okay. So look at this example. Here we're using method 2. And from now on, I hope you can stick with method 2. because in general, test point is only good for easy problems. If you have a complicated problem, you don't want to plug all those test points to the function. It takes a lot of time. Okay, so in general, we'll do method 2. I would say that's easier. Okay, let's see. I want to make the graph more interesting. Okay, so let's do, oh, I think that one is more interesting. So -5, -5, and what was that? 3x minus 1 square, and x plus 7 cube. Let's do this one, make it more interesting. Okay, all right, so first step, we set it equal to 0. And we already get the roots. They are x equals 1/3 and x equals -7. Is that okay, everybody? We already got that. So what are the x-intercepts? Well, we have the x-coordinate and the y-coordinate is 0. Okay? That is the x-intercept. And then the y-intercept is you plug in x is 0 in the formula. So we plug in x is 0. You see? -5 stays here. And then 3 times x. X is 0 minus 1 square. X is 0 plus 7 cube. Okay? We plug in x is 0. Is that okay, everybody? We plug in x is 0. So -5, 3 times 0, -1 square times 0 plus 7 cubed.
Why are we using 0?
Oh, because that's definition for y-intercept. Y-intercept is where your graph plots the y-axis. For the y-axis, your x-coordinate is 0. Remember, to find the x-intercept, you set the y equal to 0, you solve for x. To find the y-intercept, you set the x is 0 and you solve for y. Yes, everybody? Okay, now let's see. 3 times 0 is 0. What's minus 1 squared? 1, right? So we get -5 times 7 cubed. Okay, -5 times 7 cubed. What is that? Thank you. Yeah, put this in your calculator. What's -5 times 7 cubed? I know it's negative. What is that?
Negative 1715.
1715. Thank you. Okay, great. So our y-intercept, the x-coordinate is 0. Y-coordinate -1715. So these are the steps, okay? We set it equal to 0 and solve for x. That will give us the x-intercept. And x-intercept are points. Did you get a different number? Oh, okay. And then we plug in x is 0, and then we get the y-coordinate. This is the y-intercept. Okay, everybody? So, so this is the first step. A second step. Okay, so you plot those points on the graph. So 1/3 0. Let's say this is 1/3. Okay, they might not have the same scale. Okay, so put this -7. -7 is negative. So my suggestion: don't put a lot of marks. Don't put 1, 2, 3, 4, and -1. Don't put a lot of marks. Make it simple. So 1/3 is positive. Put a point here. -7, negative. Put a point there. Okay, everybody. It doesn't need to be very accurate. We want to just sketch the graph. Okay. Oh, this is the handout. And the y-intercept, 0, negative. Let's say this is negative 1715. It passed through this point, okay? And we know this is a negative number, so put a point here. Don't put a little bar there. No, don't need to. Make it simple. Make it clean. Okay. Now, what do? We look at the leading coefficients. Okay? If the leading coefficient is positive, then we start with the right upper corner. If the leading coefficient is negative, we start with the right lower corner. Okay. And if the multiplicity is odd, we cross the x-axis. If multiplicity is even, we bounce off. So keep that in mind. Now, look at this problem. What is leading coefficient? Leading coefficient, so you have this factor form, okay, is the coefficient of each factor, okay? So you keep the -5, of course, okay? You keep -5, and then do you see for this factor, what's the leading coefficient of this factor? The 3. So 3 squared. You see, everybody? So 3 squared. Next one. What's the leading coefficient for this factor? 1. So 1 cubed. Okay. So it's a product. So you look at all the leading coefficient of each factor, you multiply them. If there is a power, raise to the correct power. Okay. And we only care whether it's positive or negative. Is it positive or negative? Negative. So we start with the right lower corner. Okay, so we start with the right lower corner. So right lower corner, this side. And then you connect the dots. Okay, because the x-intercept or y-intercept, that means your graph passed through those points. Which one? Leading coefficient.
Oh.
Leading coefficient of the highest power in that factor. Yes. That's why sometimes students get confused about the y-intercept and the leading coefficient. Y-intercept, you're looking at the constants. The constants, right? Because you plug in x is 0. So you're looking at the constants. But for the leading coefficient, you are looking at the leading coefficient of each factor. Yes, everybody? Can you see the difference? Y-intercept, you're collecting the constant term because your x is 0. The leading coefficient, you're collecting the leading coefficient of each factor. So therefore, -5, they add 3 squared and 1 cubed. Okay? All right. So the leading coefficient is negative. We start with the right lower corner. And then we connect to this point. 1/3. 1/3 corresponds to the factor 3x minus 1. Look at the multiplicity, even or odd? Even. So we cross or bounce up?
Bounce up.
Bounce up. So from here, so see, we go here and then we bounce up. Bounce up and we cross this. Okay? It kind of makes sense. It's better bounce up because we want to connect this dots. Right? If you get cross, we're not able to connect it. Okay. How about -7? -7 corresponds to the factor x plus 7. Yeah. So we bounce up or cross? Cross. Oh, yes. So we cross it like that. So this is the sketch of the graph. Okay. So far, so good, everybody? Yes. So this is the second method. And from now on, please use the second method. Because when you can have a very complicated problem. Then you don't need to like pick points from each interval and plug in. You just look at the factor, whether the multiplicity is odd or even. Questions?
Okay, so for the f of 0, I guess I either was paying attention or was confused. When you're doing -5 times 3 times 0 minus 1. Never mind, I got it. I just said it out loud and I got it.
Oh, okay.
Yeah, sorry.
No problem. Yeah, when you have questions, feel free to ask. So this is the second method. All right. How about the end behavior? When x goes to minus infinity, what do you say? Infinity. When x goes to infinity, what do you say? Yeah, the y goes to negative infinity. So far, so good, everybody? Okay, so this is the method 2. So from now on, we just use the method 2. Okay, look at the next problem. So the previous problem, we were given the factor form. So this problem, we are not given the factor form, then we need to factor it by ourselves. Okay, everybody? Well, when we have 4 terms, usually how you factor is, you look at, do we have common factor? No, 8 does not have an x, so we don't have common factor. Right, everybody? Then we group the first 2 numbers together, group the last 2 numbers together. Okay? So we have f of x equals, group the first 2 numbers, first 2 terms together, group the last 2 terms together. Okay, do I put positive 8 or negative 8? Positive or negative? Negative. Yes, because if we put a parenthesis here, we need to put the sign in the middle. Okay, how about you guys take turns to answer my questions? Hi, Derica. What is the common factor of these 2 terms? Yes, x squared. What's left? Yes, very good. Quinton, what is the common factor of the last 2 terms? This last 2 terms. 4x and 8. What's the common factor? Okay, do you see they're both even? So they have a common factor of 2. But actually, 8 is divisible by 4. Right? So 4 and 8, the common factor would be 4. So we factor out the common factor 4. What is left? So Quinton, if we factor out the 4, what's left? So this term, 4 times x. You factor out the x. You factor out the 4. What is left? X. Okay. 8 is 4 times what number? 8 is 4 times 2, right? 8 divided by 4 is 2. Okay? Right? 8 is 4 times 2. So you can factor out the 4, then we get the 2 left. Okay, now do you see the common factor here is x minus 2? So we can factor out x minus 2. Diana, what's left? Yes. Can you factor the x squared minus 4? What is the difference of square? Yeah, 4 is 2 squared. What's the difference of square? A squared minus b squared is Okay, we need help. A squared minus B squared is A plus B times A minus B. Right, everybody? Okay, so even though this formula I gave you in exam 1, but it doesn't mean that we don't need it for exam 2. It's actually you need those formulas for the entire course. Okay, so please review those formula. So A squared minus B squared is A plus B times A minus B. So therefore, what is x squared minus 4? That is x 4, 2, and x minus 2. Good. Do you see we have 2 copies of x minus 2? We cancel or we group them? Group them. So it's x minus 2 squared and x plus 2. So this is how to completely factor the polynomial. Okay. All right, everybody? Okay. So now we can start. To find the x-intercept, we set this equal to 0. So we get what? Haley? What are the x? So we set each factor equal to 0, right? And when we solve for x, what do we get? Positive 2 or what? Negative 2, yes. So the x-intercept are what? 2, 0, and negative 2, 0. Good. Right, everybody clear about the process to find the x-intercept? We set the f of x equal to 0. And then you get, because you already factored, you have a product of 2 factors equal to 0, you set each factor equal to 0 and solve for x. Right, everybody?
Oh, it's squared though, isn't it?
Oh, it doesn't matter what the power is. You just set that factor. Because if you have the square, then you just take square root on both sides. But if you take the square root of 0, it's still 0. So that's why it doesn't matter what the power is, you can just set the inside equal to 0. Because you take the roots of 0, it's still 0. Good point. Okay, how about the y-intercept? Nikema. Is f of what? 0. That is what? 0, 0? Okay, you look at this formula. You plug in x is 0, but then you have negative 2 squared times 2. Ooh, what is that? 8, yes. So the y-intercept is 0, 8. Okay, now plot those points on the xy plane. 2, 0. Let's say this is 2, 2, 0 right here. Negative 2, 0 right here. 0, 8. 8 is positive, so make it up there. All right. Now, look at the leading coefficients. What's the leading coefficient? Do we look at the original form or we look at the factor form? In this case, the original form is easier. Do you see the leading coefficient? Do you see the leading term? X cubed. The leading coefficient is the coefficient of x cubed. Will be 1. Okay, so in this problem, it's better to look at the original form. If you have an original form, then it's very easy to look at the leading coefficients. But the last problem, we don't have a original form. We already have a factor form. So that's why you need to look at the factor form. Okay, but here the leading coefficient is just the coefficient of x cubed, and that's 1. 1 is positive. So you start with the what? Yeah, the right upper corner. So from here, you touch the 2. Okay, Zach, 2. What is the multiplicity? Okay, look at here. 2 is here, right? That corresponds to the factor x minus 2. X minus 2 has the power 2. So the multiplicity is 2. Then you cross or bounce off? Bounce. So right, bounce. Yeah. And we bounce it, and then we want to connect this point and get here. And then negative 2, what's the multiplicity? 1. So cross or bounce off? Cross, yes, like that. Right, everybody? Okay. Yeah, so we start with the right upper corner. Here, bounce up. Connect this y-intercept. Here, cross. So we go next. Peter, how about the end behavior? When x goes to minus infinity, y goes to negative infinity. Okay, how about when x goes to infinity, your y goes to infinity, as infinity? Yes. So we answer the problem completely. So far, so good, everybody? Yes?
I get why people get the mean coefficient. It's very important to start from the top right corner.
Yes.
But I don't get why you look at the factor form.
Oh, if you can look at the factor form, then you see the multiplicity, the leading coefficient of this factor is 1, and 1 squared times here is also 1. So you get the same answer. You can look at the factor form.
That's be why and not the unfactored.
Oh, you can look at both, but just which way makes it easier for you. Like in this problem, the original form is easier. You don't need to do the modification.
Yeah.
The previous problem, we don't have an original form. Do you want to multiply out to get the binomial form? Do you want to multiply out? You don't think so. That's why we just look at the leading coefficient of each vector and multiply out. That's easier than you expand the whole thing, right? We just look at the leading term. Yes, right. Yeah, this is a good point. Okay, any questions about how to graph polynomial? Okay, so we're good. Turning point. Turning points. So usually I just draw x squared to help me think. X squared. What is the degree? What's the degree of x squared? 2. How many turning points? 1. So the number of turning points is the degree subtract 1. Okay, so you use this example and then you can remember which one is bigger, which one is smaller.
Wait,
so
the number of turning points is subtracted 1. Okay, say that again. Sorry.
Okay, the number of turning points is at most the degree subtract 1.
Okay.
Okay. Yes. Right. So let's say every polynomial degree n has at most n minus 1 turning points. So 2 degree 2, we have 1, right? So turning point is less than the degree. So at most n minus 1. So if a polynomial has n turning points, then the degree is at least n plus 1. Okay, so your degree is bigger than the number of turning points by 1. Okay, so yes. What is the least degree that the polynomial shown below should have? Let's count how many turning points.
1, 2, 3.
Yes. So we have 3 turning points, right? So our degree is at least 4. Exactly. Is that easy? Right. Yes. Okay, how about this one?
What is the lowest possible degree of the polynomial? How many turning points? 2. Yes.
Everybody? We have 2 turning points. So it turns direction. That's turning points.
How many turning points do you need in order to add 1?
Yeah, so here we have
2 turning points. Then your degree will be, you add 1. That's the smallest possible.
If you have 2, then you add 1?
Yes.
Or if you have 1, you
We add. Okay. It depends on, do you have, if you're giving the turning point, then your degree is that number at 1. So at least that number at 1. But if you're giving the degree, then the number of turning point is that one, subtract 1. So it depends on you're given the degree or you're given the turning points. But the relation is your turning point is at most n minus 1. Yes.
So for the turning points, I guess, well, it looks confusing because it's like, it's going flat and going back.
Oh, you're
So
right.
would you argue that it's 3 and not 2?
I'm thinking about, let's see. What's the lowest?
Just, because it's making it further, and then another, so that would be.
I'm worried about like this is a turning point, so it turns here.
And then once, like it goes flat, and
It
then
goes
it turns
flat.
again.
Yes, yes, interesting. But I would say this is like a. It's okay.
It's kind of it's still okay.
It's turning because imagine you're driving a car, right? And then here it's like you're turning to the right, right? You're going to the right, and then after this point you're going to your left.
Yes, there's 3.
What?
There's 3. Sorry, there's 2 in that spot, so there'd be 3 in total.
Oh, isn't it just one? Because you
like,
turn to the right and then you turn to the left. So it's changing from the right to the left. So it's 1 point here. You change from the right to the left. Why 2?
Because.
Okay, Joy.
Okay, well, I have a problem here because I don't really. Because it's turning, obviously it's turning down from this point, and then it's just going flat like that, and then it's making it turn down.
Oh, but this is not really flat. You're saying here?
Yeah,
here?
from here to here.
Oh.
It's flat.
Okay, so the graph is not so obvious. So, okay, if it's really like that, this is more obvious, right? But then this one is like that, so you're not so sure is this really flat at this pieces, or it's just approaching to be flat slowly, but it's not really flat. Yes. Let's just assume it's not this case. Let's assume it's just getting closer to it and then turn.
Okay.
Yeah. By the way, I won't ask you this question in the exam. So yeah, we will test this topic on the exam.
Yes. Okay, so let's say it's 2 turning points. Then what is the degree then? Yeah, at least 3. Okay, what's the sign of the leading coefficient? Positive or negative? Negative, because we start with the right lower corner, right, everybody? And how about the x-intercept? And is it the multiplicity odd or even? Here, odd or even? Yeah, because we cross. How about at -3? Yes, very good. Okay, awesome. So I will let you to do the exercise for the remaining. Okay. Now let's go to session 1.8, which is our new handout 1.8. Yes. So yeah, remember, because we want to go over the examples slower, so that means we cover less examples and you do more exercise after class. Okay, everybody? And you meet a tutor weekly, so you feel free to work on those exercises with your tutor. And you meet me weekly, but this week I only see one of you completely. So okay, I know next week is spring break, but promise me that week after spring break, meet me, okay? Because I want to check on you. Did you do your homework? Did you do your quiz? Did you submit your practice exams? Did you do the exam correction and record? Okay, everybody? So, spring break, I want you to enjoy the break, but I also hope that you can have some time to study our class because I want you to be successful. I don't want you to be ridiculous. You don't want it. You don't want to be ridiculous, right? So let's try our best. Okay, and so yeah, 1.8, graphical approach of solving inequalities. So we already know how to solve linear inequalities and inequalities with absolute values. So 1.8 is to solve polynomial inequality and rational function inequality. Okay, so first graphical approach. The graph of the equation y equals 4 minus 2x is shown. This is a line, right, everybody? And what is the slope? -2. The coefficient of x is the slope, right? This is a line with the slope is -2. How about the y-intercept? 4. You mean 0, 4, right? So that's why it comes through the point 0, 4. And -2 means you go to the right 1 unit and you go down 2 units. Right? Remember, slope is rise over 1. So you can think of -2 over 1. So you go to the right 1 unit and you go down 2 units to get this point. And then you connect the 2 points, you get a line. Right, everybody? So consider the inequality. 4 minus 2x greater than 0. Greater than 0 means you want to ask, what are the x values such that your graph is above the x-axis? Right, everybody? Because this is the y. Y. So y is positive. That means above the x-axis. Okay? Above the x-axis. And y is negative. That is below the x-axis. Now, can you see on this picture? 4 minus 2x greater than 0. That corresponds to this piece. Right? That corresponds to this piece. And can we pick the number 2? Can we include number 2? No, the y will be 0, equal to 0. Right? We want it to be above. Okay? Greater than 0. Therefore, look at the x values. The x values will be less than 2. Can you see, everybody? On this piece, you project down on the x-axis, your x value will be less than 2, not including the 2. Okay, everyone? So we get x less than 2, which is this piece. All right. Now how about 4 minus 2x less than 0?
That is below the x-axis.
Right, everybody? That's below the x-axis. And then when they want to find the x values, so the x value will be greater than 2. So you project that pieces on the x-axis. Imagine there is a sun, okay, the sun right here. You want to project on the x-axis. But then this piece, look at the shadow. The shadow will be these ones, right? So to find the x value, it's like you want to find the shadow. So this is above the x-axis. You find the shadow, oh, less than 2. You don't want to include the 2 because the y equal to 0. You want to have y less than 0 or greater than 0. So you don't include it. Similarly, here, your sun is right here, then you project, this is your shadow. So that's why x is greater than 2. And this method works for all the graph. Okay, look at this one. We are given the graph, and we know x squared is a quadratic function, is a parabola. Right, everybody? And we already know, like, you can express this into the vertex form. Then you know the vertex, and you know the axis of symmetry. Right, everybody? Okay, now x squared minus x minus 6 greater than 0. That means the y is above the x-axis. Right, everybody? Above the x-axis, they are here and here. Right? And when you project down, okay, look at the shadow. Do you see we get less than -2 or greater than 3? Can you see from the picture? So those are the x-axis values. Okay, so the y greater than 0, and when you project down, your x is either less than -2 or greater than 3. If you want to use interval notation, you put minus infinity to -2 parentheses because you don't want to include the endpoint. Union 3 to infinity. Right, everybody? This is part A. How about part B? Less than or equal. Less than means is below. Ooh, which is this piece, right? But or equal. Equal means you include the endpoint. Okay, so y is less than equal to 0. Can you tell me what the shadow, what are your x values? -2, parentheses or brackets? Brackets, 2, that point is 3, parentheses or brackets? Brackets, yes, exactly. Okay, everybody? So, okay. We below, this is P, and then we project on the x-axis, this is the shadow, and we also include the endpoint. Right. Okay, we will continue after the break. But please review your notes. I hope you can still remember something we teach this week. Okay?
For the homework, on the calendar it says 2.4 is the last 2.6. But the homework assignment says 2.4 is the
Oh. Oh, how about on the fourth assignment? Right? Oh, well. Maybe I forgot to assign 2.6. Let me fix it. Okay, let me fix it. Okay, thank you.
Bye. Happy spring break.